This is part 2 to the review for test 4. Number 7 asks us to expand this as much as possible and then evaluate any logs. This is where you are using your 3 properties of expansion. Log base 4 of a quotient will break into, initially, log base 4 of the top minus log base 4 of y cubed. Now there's 2 things that we can do here. Log base 4 of 64, we can evaluate that. That is 3. The reason it's 3 is that 4 to the 3rd power is what gives us 64. The other thing we can do here is detach this power and bring it down in front to become a coefficient, so it becomes 3 log base 4 of y. Log base 3 of this product in the top over the product in the bottom will break into log base 3 of x squared plus log base 3 of m. Now you need to be careful. This whole thing is in the bottom. That means there's going to be a minus in between. So log base 3 of y minus log base 3 of z. The way I look at this is if it comes from the top, it gets a plus sign in between. If it's in the bottom, it's going to get a minus. So now I just have to clean up these exponents, bring the 2 in front, and this will be 2 times log base 3 of x. The log base 3 of m stays where it was. Same thing for the rest of this. So I'm just recopying those last 3 terms. For this one, ln works the same way. It is a quotient, so it is ln e minus ln x. And you should remember that ln e is 1. So this just simplifies into 1 minus ln x. Because this is a quotient, we will write this as log base b of radical y minus log base b of c cubed. You can't deal with the radical as a radical, so we must write it in rational exponent form. So this is log base b of y to the 1/2 minus log base b of c cubed. Then we have to take these powers and dislodge them and bring them down in front to be coefficients. So this becomes 1/2 log base b of y minus 3 times log base b of c. Same steps over here. Log base 6 of 36 minus, because it's in the bottom, log base 6 of radical x plus 1. Log base 6 of 36 is 2 because 6 to the 2nd power is 36. This I need to write as a rational exponent. The square root of x plus 1 is the fraction 1/2, and then bring the 1/2 down in front. This is the exact opposite of the problems we just did. This is where you are condensing it back together. You're going to write it as a single log or single natural log, and then evaluate any expressions. So we're going to write ln 1 time. There's a plus in between here, so this and this are being multiplied together, so that gives us 7x on the top. There's a minus in front of this, so it goes to the bottom. This one's got an extra step, and that is any coefficients need to come back and become exponents before you do anything else. So this is log x to the 5th minus log of 2x plus 4. Now I will write log 1 time. And remember, log is log base 10, but you don't need to write the base 10 here. So this is log x to the 5th over, because of the minus, 2x plus 4. Bring the powers back, or bring the coefficients back to be powers. So this is log base b of x squared plus log base b of y cubed. So we will write log base b 1 time. And this is a plus in between here, so these are being multiplied. X squared, y cubed. Bring your powers back. So this is ln x cubed minus ln y to the 1/3. Your directions up here tell you to convert rational exponents to radical form. So I've got to take this and go back to the radical. So this is ln x cubed minus ln of the cube root of y. Then I can go to ln. There's a minus in between here, so the x cubed is on the top and the cube root of y is on the bottom. Probably the easiest thing to do to start with is distribute the 1/3. So this is 1/3 log x minus 1/3 log y. Bring the powers back. So this is log x to the 1/3 minus log y to the 1/3. That's the cube root. So this is log of the cube root of x minus log of the cube root of y. Write log one time. There's a minus in between, so we divide. So this is the cube root of x over the cube root of y, which algebraically can be simplified into log of the cube root of the fraction x over y. Change of base formula says log base a of b can be converted and thought of as log of b over log of a. We use this whenever you're doing a base that cannot be stuffed directly in the calculator. You can't press log base 4 of 28 on the calculator. You can press log base 10, but you can't do that with the log base 4. So using this formula, which you do need to memorize, we would just evaluate log of 28, which is that, over log of 4. So the base goes in the basement, it goes in the bottom. But one thing you've got to be very careful with on your graphing calculator is when you press log, you get a front parenthesis. You have got to remember to close off that parenthesis before you hit divide, and then closing that off. And log base 28 over log base 4 rounded to 3 decimal places is 2.404. Same exact thing here. This would be log of 167 over log of 7. Be sure you close off that parentheses in the top and in the bottom, and this works out to be 2.630. Number 10 is asking us to solve exponential equations. Sometimes you can convert to common base, and sometimes you must actually take the natural log of both sides. This is an easy one because 32 is the same as 2 to the 5th. Now where do I get 5? I could play with the calculator and keep hitting 2 to the 3rd, 2 to the 4th, 2 to the 5th till I land on 32. Or I could do my successive divisions, keep dividing by 2, and you will have a string of 5 2's written out. Once you have these two expressions equal and the bases are already equal, all we have to do is take the exponents and set them equal and solve. So x is 6. This is a little more complicated because there is no power that goes on 4 to give me 128, but both of these can be thought of as base 2. So 2 squared is another way to think of 4. So this is 2 squared, all raised to the xth. And 128 is 2 to the 7th. Same deal, how do I get 7? I can play with the calculator till I land on 128, or I can do 128 and keep doing my successive divisions, and I will end up with a string of 7 2's. Now, exponent law, 2 to the 2nd raised to the x power is just 2 to the 2x equals 2 to the 7th. These two expressions are equal, the bases are equal, therefore the exponents must be equal, and all you have to solve is 2x equals 7, divide by 2, and x is either the fraction 7/2 or the decimal 3.5. Same thing here. I can do 1 over 81 in terms of a base of 3, so I'm going to leave this as 3 to the x plus 2. 1 over 81 will be 3 to the negative something. How do I know it's negative? Because this is a fraction. The fraction would have been created with a negative exponent. What power goes on 3 to create 81? It is 4. Either use your successive divisions or use your calculator. Expressions are equal, bases are equal, so just set these equal. So you have x plus 2 equals negative 4, x equals negative 6. These are not going to be done with a common base. These are done by taking the ln of both sides. When you recognize that you don't have a common base, you're going to do the ln of both sides. So let's spread this out a little bit. And I will take the natural log of both sides. ln e is going to cancel out. All I have is a nice neat x minus 3. ln 4 I'm going to have to evaluate on my calculator, which is about 1.386. And then solve this for x, add 3 to both sides, and x is 4.386. Spread this out a little bit before we do the problem. I will take the natural log of both sides, and the reason you know you have to do that is because there is no power on 5 that's going to give me 27. So take the natural log of both sides. Keep in mind that this is an exponent. It happens to be a binomial, so I put it in parentheses, and this is now going to come down in front. So this is x minus 2 times the natural log of 5 equals the natural log of 27. From here, because I want to solve for x, I'm going to divide both sides by the natural log of 5. What that does for me is it gets rid of the natural log on the left side, and I have a plain old x minus 2. Leaving this as ln of 27 over ln of 5 for just a minute. I want to get the x alone, so let's add 2 to both sides. So my answer is x equals 2 plus ln of 27 over the ln of 5. Now, math lab problems just wanted you to leave it like that. But now we're going to evaluate this. Don't forget to put the parentheses around the ln of 27, just like we did with the parentheses around log. And when you type all that in, you will get 4.048. Before I want to take the ln of both sides, I have to have the e isolated. So add 10 to both sides. And you're looking at e to the 2x minus 5 equals 34. Take the natural log of both sides. Squeeze that in. ln e goes away. I have 2x minus 5 equals the ln of 34. And again, I'm going to leave this as ln of 34 until I'm finished here. I'm going to put that in parentheses, though, to remind me when I use the calculator. Now, get this so that the x is solved. So add 5 to both sides. So you're looking at 2x equals 5 plus the ln of 34. Then divide everything by 2. Be careful when you do this on the calculator. If you enter 5 plus ln of 34 divided by 2, the calculator is only dividing the natural log of 34 by 2. So I think the easiest thing to do for you guys is to do the numerator on the calculator, do 5 plus the natural log of 34, hit enter, and then divide that number by 2, and this will work out to be 4.263. One more of these, and it's the one that requires the most work. We will take the natural log of both sides. So now I have natural log 2 to the 3x minus 1 equals natural log 6 to the 2x plus 1. All I did there was rewrite it a little bit more spread out so that you could see. When you have the natural log to a power, the power gets to come down in front and become a coefficient. In parentheses, because it's a binomial. Same thing over here, gets to come down and become a coefficient. Keep it in parentheses. I would like to divide both sides by the natural log of 2. Cancels out. I have 3x minus 1. And on this one, because I had powers on both sides, the easier way to go on this is going to be to actually do that arithmetic right now on your calculator. I know on the previous 3 or 4 we waited to the end, but right now we need to evaluate natural log of 6 divided by natural log of 2. Remember, parentheses around those, and this works out to be 2.585. Now that's that parentheses times this. That is a distributive property. We're used to having the coefficient in front, but we need to distribute 2.585 times this parentheses, which gives me approximately 5.17x plus 2.585. Of course, this side stays 3x minus 1. Now this is just your plain old equation to solve. I will subtract 3x from both sides, which gives me negative 1 equals 2.17x plus 2.585, and then add or subtract 2.585 from both sides, and this is negative 3.585 equals 2.17x, and then just divide everything by 2.17, and x is negative 1.652.